Welcome to multiple choice question 19 of the 2006 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. Now before we move on, I'd just like to point out that the use of a CAS calculator may assist in answering this question, but there is still a considerable amount of setup that you need to do by hand before that will work. So for question 19 we consider the simultaneous linear equations as shown, and we want to find the value of m so that there's no solution to that system of simultaneous equations. So to have no solution, we actually want the same gradient but a different y-intercept. So to compare gradients and y-intercepts, we actually want to rearrange these equations into their y equals form. So this first equation here, if I do that in green, we're going to try and get y by itself, and I'm going to start by subtracting the m minus 2 times x. So we would actually end up with 3y is equal to negative m minus 2 times x plus 6. And then we want to get y by itself by dividing by 3. So we find that y is equal to, and in the same step I might just simplify this out a little bit, we'd actually end up with this being negative m plus 2. So that's just distributing that negative through the bracket, divided by 3, and that's multiplying x, so this coefficient here is the gradient. And then we'd still have plus 6 over 3, which is plus 2. So this y-intercept is 2. We'll do the same thing for the second equation. We're going to get y equals for this as well. So starting by subtracting the 2x, we'd find that m subtract 3 times y is equal to negative 2x plus, and then I'm just going to put this in a bracket, the m subtract 1 that was already on the right hand side of that equation. Then we can divide everything by the m subtract 3, which is multiplying y. So that gives us y equals, and we'd have negative 2 over m subtract 3 when we divide by m subtract 3, and that is going to be multiplying x, so we can now see the coefficient of x is that fraction, plus, and then we'd have the m minus 1, and it would also be divided by m subtract 3. So that fraction at the end is the y-intercept. So going back to the first thing that we discussed, is to get no solutions, we want the same gradient but a different y-intercept. So the first condition we have is that we want the same gradients. So therefore, the equation that we can set up is the negative m plus 2 over 3 must equal the gradient of the second line, which we found to be negative 2 divided by m subtract 3. And this is where we can use a calculator now to help solve that equation. So we now have our first equation to solve. So on the calculator we can go into the main menu and we want to set up that equation. So clicking on keyboard we can bring up a fraction, and then we wanted negative, and I'm going to use m rather than some other variable. We'll use the actual one we're using. So we'll use negative m plus 2 over 3 is equal to, and then we need another fraction, which is negative 2 over m. So we need to go back into variables, subtract 3, and we can solve that for m. So interactive equation inequality solve, and then instead of variable x, we want to put m in there and hit OK. So from the calculator, we can see that m equals 0 and m equals 5 both satisfy that equation, which will guarantee that the gradients are the same if we have m is 0 or m equals 5. The second thing that we wanted was different y-intercepts. So therefore we can set up another equation. So from our first equation we knew the y-intercept was 2, and we actually want these to not be the same. So I'm going to use a not equals 2 sign there. And the y-intercept of the second line that we found was the m subtract 1 divided by m subtract 3 fraction. So we want that fraction to not equal 2. So now that we have this second equation, we can go back to the calculator and use that to help solve it. So we want a fraction, and then we want variable, and we want m subtract 1 divided by m subtract 3. And we want it to not equal 2. So you may not have ever used this before, but under Math 3 there is a not equals 2 sign. So we can do that fraction is not equal to 2. And we can still solve that. Equation inequality, solve for variable m. And this will say that m cannot equal 5. And from the calculator, we found that m cannot equal 5. So the two things we've found is that m is equal 0 or 5, and that came from the same gradient setup. But then we found that m cannot equal 5. So that means that the only answer that we've got left is m equals 0. So that turns out to be the correct option, and that's option E for question 19. And now while we're here, we can actually see graphically that this all checks out. So if we go back to our equations, we actually had variable m subtract 2 multiplying x plus 3y is equal to 6. So that was the first equation. And now I'm going to use math 3 and do given that m equals 0, and that will substitute that in for us, and that gives us this straight line equation. And then for our second one, we actually had 2x plus, and then in brackets we had m, so I need to go variable m subtract 3 times y equals, and then we had m subtract 1, so m subtract 1 on the right hand side. And once again, I'm going to use math 3 given that m equals 0, and that will give us this equation. And if I sketch both of those by dragging them down one at a time, we can see that we do in fact end up with parallel lines, and that means that there'd be no points of intersection or no solutions to that set of simultaneous equations, which is what we were after. From the examiner's report, we can see that this was another challenging question in the 2006 exam, with only 35% of students getting the correct answer for this question. The examiner's report also includes some commentary on how they approached this question, and they have discussed that to have no solutions or infinitely many solutions, the ratio of the coefficients of x and y must be equal, which is essentially the same as what we did on the previous slide, by letting the gradients of those two lines be equal. So that also found the values of 0 and 5, and then to have no solutions, the examiner's report goes on to say that the y-intercepts must be different, so m equals 0 was the only option that satisfied that condition.